Hi everyone, my name is Ankita and I am here to present task 7.3D from the unit SIT 210, which is based on Raspberry Pi PWM. Let us see what is the content of this video. First is overview, second one is hardwares, third I will tell you software setup, fourth circuit diagram, fifth one is coding part and the last working video. So the objective of this task is to work with PWM on a Raspberry Pi and control functionality of a device, for example a vibrating motor or an LED. You are required to build an embedded device that detects if an object is approaching and notify using vibration, motor, buzzer or the brightness of an LED. The device will use ultrasonic sensors to detect if a solid object is approaching and alert the user. As the object gets closer to the device, the sound gets louder or higher pitch, or if using an LED, the LED would become brighter, or if using a vibrator motor, the vibration will be higher. So, the hardware required to make this ultrasonic sensor, LED, breadboard, jumper wires, HDMI cable to data transfer and a Raspberry Pi. Now we will look at circuit diagram. The trig pin of ultrasonic sensor is connected to pin number 11, the echo pin connected to pin number 15 and an LED is connected to pin number 12. This is a software setup. We move further on software setup. We will need Raspberry OS installed and real VNC to remotely control a Raspberry Pi, which we have set up in previous task. Now we move on coding part. From above, these are the libraries. First one is import the Raspberry Pi GPIO library for GPIO control, and the second one is the time library for timing operations. Next, this set the GPIO mode to board using physical pin numbers. This line defines the GPIO pin number for the trigger of the ultrasonic sensor. GPIO trigger. GPIO pin number of the trigger of the ultrasonic sensor is set to 8 and the echo pin number of the ultrasonic sensor is set to 10 and an LED is connected to pin number 12. Next one is this define a maximum distance threshold in centimeters. This set the LED pin to PWM that will vary from 1 to 100. Next, LED will start from the off position, start the PWM with a duty cycle of 0. This section of the code sets up the necessary GPIO pins, initializes the LED for PWM control and sets the initial LED brightness to 0. That is off. Next, set trigger pin to high when it will trigger a signal. Start time. This initializing two variables for time difference. Now, time difference between start and arrival. This section defines a function called distance that calculates the distance using an ultrasonic sensor. It triggers the sensor, measures the time it takes for signal to bounce back, that is echo, and then calculates the distance based on the speed of sound. Then the loop while call the distance function to calculate the distance and then print the measured distance. Now in if loop, check the distance is under the maximum distance. Then sleep for a short time. This section of the code runs in a loop and continuously measures the distance using the distance function. It adjusts the LED's brightness based on the measured distance. If the distance is less than or equal to set distance, it changes the LED's brightness proportionally. If the distance is greater than set distance, it turns off the light. Last part of this code, these lines finally stop the LED PWM and clean up the GPIO pins when the program is terminated. This ensures that GPIO resources are released properly. Now we will see working video. Thanks for watching this video.